Nice to meet you. I'm Father Choppai and you're watching my YouTube channel School of Advanced Chemistry. Today I'm going to discuss acid-base salt. Few basic, quick and important points for O-level and IGCSE chemistry. Acid, base and salt. Let's get started. I'm going to start from the acid. Acid, a substance that releases a positive ion in aqueous medium, is called acid. Any substance that is supposed to release a positive ion in aqueous medium is called acid. For example, HCl, H2SO4 and methanoic acid or ethanoic acid. Basically, if hydrogen is present with halogen, HCl, HBr, Hi, then it is said to be an acid. When hydrogen is present with SO2, with NO2, with PO4 and so on, basically hydrogen with non-metal oxide ion like sulfuric acid, like nitric acid, is also said to be as an acidic compound, or that substance is called acid. Same is the case if the compound is having COOH. If the hydrogen is present with COO group, then this hydrogen or this compound is also said to be an acidic compound. Next one is a base is a substance that can accept a positive ion and neutralize the acid. Any compound that has capability to accept a positive ion and any compound that can neutralize the acid, that is the basic definition of, that is the typical definition of the base. For example, metal oxide, metal hydroxide, metal carbonate and ammonia. So metal oxides, metal hydroxide, metal carbonate and ammonia, these four type of substances are generally known as bases. Generally they are called bases. Metal oxide can act as a base, metal hydroxide can act as a base, metal carbonate can act as a base, and ammonia is definitely a base. A substance which releases OH negative ion in aqueous medium is called an alkali. It is also said to be a base. Basically, what is an alkali? Any compound, any substance that is losing OH negative ion in aqueous medium is called alkali. Basically, there are the different compounds, those are having OH group, or sometime even they are not having OH group, but they can generate OH group in water and aqueous medium with water molecules. And these are called bases as well as alkalis. For example, sodium hydroxide and barium hydroxide. Group 1 hydroxide, group 2 hydroxide ion. These hydroxide can accept a positive ion, so they can be called as base. And these compounds have probability to lose OH negative ion in aqueous medium, so they are said to be alkali as well. So number one, any base, if it is water soluble, is called, its second name is said to be an alkali. Base, any compound that accepts H positive ion. Alkali, a compound that accepts H positive ion, as well as it's losing OH negative ion in aqueous medium. So these two properties belong to the alkali, and base is just that is going to accept the H positive ion and neutralizes the acid. Metal carbonate having dual properties. Metal carbonate act as bases as well as salt. So all metal carbonate, sodium carbonate, magnesium carbonate, copper carbonate, if the carbonate is having metal as the one part of its compound, then they can act as bases as well as salts. Once again, any species, it may be a salt, is said to be an acid if it is going to react with a base. If it is neutralizing the base, any species is said to be, any salt is said to be an acidic salt if it is neutralizing the base, Any species of salt is said to be the base if it is neutralizing the acid. Any species of salt is said to be a base if it neutralizes the acid. So there are some salt, those can neutralize the acid. There are some salts, those can neutralize the base. If a salt that is neutralizing the acid, it is said to be a base. If a salt is going to neutralize a base, it is called an acid, and so on. Any acid can react with a base. Any acid, any dilute acid or concentrated acid can react with a base to neutralize the base. So acid base, whenever they are allowed to meet together, they neutralizes themselves to make different sort of compounds. Sometimes they make salt, sometimes they make salt and water, and sometimes they make salt, water and carbon dioxide gas, as far as your syllabus is concerned. For example, when HCl is allowed to react with ammonia, it reacts with ammonium chloride, just salt. When HCl reacts with sodium hydroxide, it's going to make sodium chloride and water. When hydrochloric acid is allowed to react with any base like sodium oxide, it's going to make sodium chloride, salt and water. And in the last one reaction, when hydrochloric acid or any other acid, when it is allowed to react with carbonate, it's going to make salt, carbon dioxide and water. So whenever acid and base meet together, there is the formation of salt only. There is the formation of salt and water only, you can say. And sometimes there is the formation of salt, water and carbon dioxide. These all points are very much true as far as O-level chemistry or IGCSE chemistry syllabus is concerned. Come to the next one. Dilute acid react with the metal. Those are more reactive than copper or hydrogen, you can say. Any acid, any dilute acid can react with a metal with which metal is more active than hydrogen or it is more active than the copper in the reactivity series. And at that time, hydrogen gas is given off. Hydrogen gas is given off. Dilute acid react with the metal. Those are more active than copper to make hydrogen gas. For example, sodium is a more active metal than copper. When it is allowed to react with the HCl, it's going to make hydrogen and salt. Same is the case with the iron. When iron is allowed to react with the dilute HCl, it's going to make hydrogen and iron chloride. And if copper is allowed to react with the dilute acid, no reactions over here. There is no any sort of formation of hydrogen gas in this case. Copper and the low reactive metals react with concentrated acid, but this time no hydrogen gas is formed. Different other gases are formed, but they cannot displace hydrogen from the acid. So copper and low reactive metal can react with acid. Yes, it is true, but they can react with a concentrated acid. And this time there is no any sort of formation of hydrogen gas. This time there is no any sort of formation of hydrogen gas. For example, when the copper is allowed to react with a concentrated nitric acid, then this phenomena is going to happen. Copper plus concentrated nitric acid goes to 2 mole of nitrogen dioxide and water. So NO2 gas, nitrogen dioxide gas, is going to form. Whenever any metal that is less reactive than that of hydrogen in the reactivity series and it reacts with concentrated acid. Yes, it can react with a concentrated acid, but this time there is no formation of hydrogen gas. There may be the formation of NO2 gas, there may be formation of sulfur dioxide gas and so on. Next point is acid can be used in the precipitation. Acid as a component, as a reagent, can meet with any other reagent, with any other component, with any other substance to make an insoluble compound. It is said to be precipitation reaction. For example, when barium nitrate is added into the hydrogen sulfate, or that is said to be sulfuric acid, there is the formation of barium sulfate and nitric acid. So this reaction is said to be precipitation reaction because two aqueous compound, barium nitrate is aqueous and insoluble, sulfuric acid is soluble. When two soluble compounds are mixed together to make an insoluble compound, that is barium sulfate, and one soluble compound, that is HNO3. So basically in this reaction only barium sulfate is insoluble, and this reaction is said to be precipitation reaction. In this reaction, particularly in this reaction, sulfuric acid is not going to behave as an acid. It's going to behave as a simple reagent. So in this reaction, the function of sulfuric acid is not as an acid. Precipitation reaction gives only one solid, as I told you, compound by the reaction when two soluble compounds are meet together. Acid produces hydrogen ion only in the presence of water, so acidity needs water. Water is required to the acid to show its strength, to show its nature, and that is the same case for the alkali. That is true for the alkalis as well. Acidity needs water, basicity or alkalinity also needs water. Acid and alkali both require water, aqueous medium to lose a positive ion and to lose OH negative ion for the alkalis. The common name of sodium hydroxide is caustic soda, or it is also said to be soda lime. Caustic soda and soda lime are the common names of sodium hydroxide and NaOH. Baking soda and also known as cooking soda are the common name of the sodium hydrogen carbonate, but Na2CO3, that is sodium carbonate, its common name is washing soda. Washing soda is sodium carbonate that is having no hydrogen in it, but baking soda or cooking soda is the sodium hydrogen carbonate. It is the property of all alkalis. They liberate ammonia gas whenever they are allowed to react with ammonium salt. When ammonium compound, ammonium chloride, ammonium nitrate, ammonium phosphate, any other ammonium compound, when it is allowed to react with sodium hydroxide, with any other base, and at high temperature, when the sodium salt is heated with sodium hydroxide, then there is a formation of three basic compounds. Number one, ammonia gas. Number two, water. Number three, there is the formation of a salt, that is NaCl. Water soluble bases are called alkalis. Water soluble bases, as I told you, they are said to be the alkalis and so on. To distinguish between strong and weak acid or strong and weak alkali, we need to check the properties, pH of that acid or alkali, rate of reaction that is given by that acid or alkali, or we can perform titration to sort out the concentration of that acid or alkali. In case of strong acid, pH will be less than 3, 0, 1 or 2. In case of weaker acid, pH may be 5, 6, 6.5 and so on. Stronger acid give high rate of reaction, weaker acid gives slow rate of reaction. In titration method, you can find the exact concentration of the positive ion given by that acid. So same is the case with alkalis. In case of alkali, pH should be higher, 10, 11, 12, 14. In case of weak alkali, the pH should be 8, 9 or 10. Rate of reaction of the strong alkalis will be higher. Rate of reaction of the weak alkalis will be lower 1. Titration is again the good tool to check the exact concentration of OH negative ion that is produced by that alkali. So by changing the pH, by changing the rate of reaction, by performing the titration, we can find the strength of acid or alkali. Acid or basic solution are treated themselves so as to neutralize them finally. In any reaction, whenever you are going to use any acidic catalyst or basic catalyst, then we finally add acid or base into that solution for the purpose of neutralization of that catalyst. Whenever acid and base are meeting together, the basic perspective is to neutralize them to make neutral solution. Hydrogen ions from the acid and hydroxide from the alkali meet together, and this is called acid-alkali neutralization reaction. In acid-alkali neutralization reaction, the basic reaction is between H positive ion and OH negative ion. And whenever they are going to meet together, they are going to form H2O water. And here is the ionic equation for all type of acid-alkali reaction. All type of acid-alkali reactions are going to show this sort of ionic equation. This is the common ionic equation for all type of acid and alkali, not the base. Acid and alkali reaction, this is the ionic equation, and it is also indicating that there is the combination of equal mole of H positive ion and OH negative ion. I mean 1:1 combination of the moles of OH negative ion and H positive ion is over here. Next point, ionic equation for the other acid-base reaction may be different. For example, if the soluble carbonate is allowed to react with the acid, this is the ionic equation for soluble carbonate. For example, when the sodium carbonate is allowed to react with HCl, then the ionic reaction will be equal to 2H positive ion aqueous, carbonate 2 negative ion aqueous goes to H2O plus CO2 gas. This is the ionic equation for soluble carbonate and acid reaction. In case of insoluble carbonate and acid reaction, yes, this is an acid-base reaction, not acid-alkali reaction, and this time the ionic equation is this one. You can make the ionic equation according to the given substances, according to the given solutions. You can also check this lecture from my YouTube channel. I have made this lecture in my previous lectures. That is about how to make the ionic equation. What are the 4 basic steps to make the ionic equation? Next one, sulfuric acid gives 2 types of salts when it is allowed to react with the sodium hydroxide. Number 1, sodium bisulfate or sodium hydrogen sulfate, and second salt is sodium sulfate. In first step, sodium hydrogen sulfate is formed. When sulfuric acid is allowed to react with sodium hydroxide, in first step there is the formation of sodium hydrogen sulfate, and in second step sodium hydrogen sulfate again react with sodium hydroxide to make sodium sulfate. So whenever you are going to react with dibasic acid, it is said to be dibasic acid because it is having 2 hydrogen atoms, and these hydrogen can be replaced, but this replacement is done by a turn. So whenever the sodium hydroxide is allowed to react with any alkali, any base, it is going to make 2 salts. In case of sodium hydroxide base, the first salt is sodium hydrogen sulfate, the second one is sodium sulfate. Turn by turn, I mean hydrogen of the sulfuric acid is removed step by step. In next cases, similarly phosphoric acid that is having 3 hydrogen in its 1 molecule. So these 3 hydrogens are again substituted by the metal. I mean these hydrogen are replaced by the metal turn by turn, step by step. So 3 different salts are formed when sulfuric acid is allowed to react with the sodium hydroxide. That is sodium dihydrogen phosphate, then sodium hydrogen phosphate, and this is the sodium phosphate. So whenever you are going to react, I mean when H3PO4 is in excess, then only 1 hydrogen is replaced, and when sodium hydroxide is in excess, then all hydrogen will be replaced turn by turn. So phosphoric acid can make 3 salt, 3 different compounds as a salt, 3 different salt whenever it is allowed to react with the sodium hydroxide or any other base. Next one, metal oxide are either bases, for example sodium oxide, calcium oxide, or sometimes they are said to be amphoteric oxide. So metal oxide are of 2 types. Number 1, it may be the basic oxide or it may be the amphoteric oxide. Only 3 oxides are amphoteric in your syllabus: zinc oxide, aluminium oxide, and lead 2 oxide. Except these oxide, all metal oxide are said to be just basic oxide. These are amphoteric oxides. What are the amphoteric oxides? These oxides neutralizes the both. They are showing dual properties. They can neutralize the acid as well as the bases. So these oxide can neutralize the acid and base both. The next point is non-metal oxide are often acidic oxide, like sulfur dioxide, like carbon dioxide, like nitrogen dioxide, like phosphorus 5 oxide. I mean usually non-metallic oxides are acidic oxide. Some non-metallic oxide are neutral like carbon monoxide. Some non-metallic oxide are amphoteric like H2O. H2O is also a non-metallic oxide. The last one, silicon dioxide. It's a metallic oxide. Silicon is basically a metalloid, you can say. It's not a pure metal. Silicon dioxide is an acidic oxide. Silicon dioxide is an acidic oxide, but it cannot dissolve itself into the water. It reacts with concentrated hot sodium hydroxide or potassium hydroxide. I mean, silicon dioxide reacts with hot concentrated alkalis. Strong alkalis are required to react with silicon dioxide, but silicon dioxide is basically showing the acidic nature, or it is said to be an acidic oxide. And you know, all acidic oxides neutralizes the bases and alkali. That's all about today, about these major 25 points. Thank you very much. Have a nice day.